All right, our objective for this lesson is to discover the relationships in special right triangles. I'm going to make two separate videos here. There's two separate special right triangles. The first one is called your 45, 45, 90. That's what this video is going to focus on. And the second one will be our 30, 60, 90. So here's the idea, a basic idea. You already know how to work with right triangles. You know that if you have a right triangle, you can use the formula a squared plus b squared equals c squared. And basically, as long as you have two of these three sides, you'll be able to calculate the third. Now, what you cannot do based on the math that you know right now is if you only had one of the three sides, you, as of right now, have no way to work out what the other sides would be. And that is where these special right triangles come in. If we understand this, we will basically be able to find the missing sides when we only have one side. Now, the one catch is that, or the one limitation is that we have to know that, we're dealing with a 45, 45, 90. But as long as we have that kind of triangle, 45, 45, 90, and if we have one of these three sides, we will be able to calculate the other two sides. So for example, if I knew this was 7 units here, after this lesson, you're going to be able to find these two missing sides. Now, if you were in class with me right now, I would ask you to get out your protractor and I would ask you to draw me some 45, 45, 90 triangles, and you would use a ruler to take your measurements, and then we'd go around the room and find out what everyone came up with. Now, because we're not in class together right now, obviously we can't do that, but what I can do with you is I can share with you the results from last year. There was one person that drew a 45, 45, 90 triangle, and they told me that they had a 4.7, a 4.8, and a 6. There was another person who drew me 45, 45, 90, and they had 6.1, 5.9, and 8.3. And we'll do maybe two more here. A third person had 10.5, 10.5, and 14.7. And there's one other person that had, we'll share this one. They had 5.4, 5, and these were in centimeters if you're curious. I had to measure everything in centimeters. Okay, now I had other ones, but this will be enough for us to work with. The first thing that should jump out at you is these top two rows right here, and definitely specifically these two, because these are perfect. Now, these two are a little bit off. If you remember, you have a theorem called the converse of the base angles theorem. It's theorem 5.7 in your textbook. And basically, the converse of the base angles theorem says that, hey, if I have a triangle and I know that I have two angles that are congruent to each other, then the conclusion I can draw is that my triangle is going to have the opposite sides congruent. So opposite of this angle would be this side. So this side and opposite of this one was here. So I will have these two congruent sides here. Now, if this triangle, if these are both 45s down here, 45, 45, then I know for sure that these two guys have to be congruent to each other. And that's exactly what these two people got. So in general, for every single 45, 45, 90 triangle in the world, I am going to have some number across from the 45, and we'll just call that X to make it a generalization. And across from this 45 will be exactly the same. These two sides absolutely have to be congruent. Obviously, these a little bit of error in measurement with these two people, but that's okay. When you're using rulers and protractors, you might not get things to work out perfectly. The thing that's complicated, though, is what is the relationship, from here to here? So if I know that this is some value x, and here, let's use a specific number. If I know that, let's say I knew that this was 2 units, and this is 2 units, and this is a 45, 45, 90. What would this guy right here, what would your hypotenuse have to be in that situation? So the next thing I would have asked you to do if you were in class with me right now is I'd say like, okay, so what would I multiply 5.4 by to get to 7.7? And what would I multiply 10.5 by to get to 14.7? And how do I get from here to here? What would I multiply 5.9 by to get to 8.3 and 4.8 by to get to 6? And I can tell you those answers, at least rounded. This one here, if I multiplied 4.8 by 1.25, that's going to give me 6. With this one here, if I multiply 5.9 by 1.41, I'll get to 8.3. If I take my 10.5 and multiply that by about 1.4, I'll get my 14.7, and my 5.4 times 1.42 will give you my 7.7. And if you're wondering how would you calculate this, you just set up a simple equation, 5.4 times what number x would equal 7.7, and just divide both sides by 5.4, and you'll have your answer. So 7.7 divided by 5.4 will tell you exactly what you need to multiply by, and I already told you this is about 1.42. Now, is there a better way? So first off, this one here is a little bit off. So once again, the person who made this triangle, they were a little bit off in their method, but not terrible, but a little bit off. Your exact answer is actually going to be the square root of 2. And if you type the square root of 2 in your calculator right now, let's take a look at that. In decimal form, the square root of 2 is about 1.41, rounded to the nearest hundredth. So this one here is right on. It is perfect. Whoever made this triangle in my class did an excellent job. So what that means is that for every single right triangle that is a 45, 45, 90, take this value right here that is across from my 45, multiply it by the square root of 2, and you'll get this value right here. So for this problem, it's the square root of 2 times x, and that tells you what this spot is. Now with this specific example, if across my 45 is 2 units, then this as an exact answer would be 2 square root of 2. And the other thing you have to be sure that you're clear on is that if I'm multiplying by root 2 to get from this side to my hypotenuse, what if they gave me my hypotenuse and I wanted to get this side? Well, then the answer is that if they give me this value, my hypotenuse, and I want to get to this side that's across my 45, I'm just going to divide by the square root of 2. And that's where you have to be comfortable with working with radicals a little bit and dividing by the square root of 2. So here is your technical definition straight from your textbook. If you have a 45, 45, 90 triangle, the hypotenuse is root 2 times as long as each leg. So whatever these legs are, multiply by the square root of 2, and that'll give you your hypotenuse. Here is it written in a slightly different way. In a triangle whose angles have the measures 45, 45, and 90, the lengths of the sides opposite these angles can be represented by x, x, and x root 2, respectively. Now notice this one here doesn't have x's, but it has the numbers, but it's the same idea. For every 1 unit that I have here, I multiply by the square root of 2, and this hypotenuse has to be root 2. Or if I started with this, divide by the square root of 2, and that gives me my side that's opposite my 45. Hopefully in the next video, we'll take a look at some specific examples and help you guys make sense of this.